So in this video I want to discuss what is a p-value. Understanding what a p-value is really important to understanding how to do a hypothesis test and what does it mean when you're doing a hypothesis test. How is it that you figure out whether or not you're accepting or rejecting a null hypothesis? It all has to do with the p-value. Okay, so I'm going to explain the p-value with regards to a t-test. However, you could, p-values can be for any test. Okay, so I just want to explain it with the t-test. So say that we're testing the hypothesis. So our null hypothesis is mu, some mu equal to, some mu equal to 0. And then we're testing if it's not equal to 0. Okay, so if the population mean is equal to 0 or not, that's what we're testing. Okay, so we're going to do a t-test. Okay, I said I was going to be doing this with respect to the t-test. So we calculate the t-statistic. That's the first thing that you do. Calculate the t-statistic. Second thing you do. First thing you do is you find what your null and alternative hypothesis are. So second thing, you calculate the test statistic. Well, the test statistic in this example would just be x bar, okay, where x bar is the sample mean, minus 0, right, because we're testing if it's equal to 0 or not equal to 0, and then divided by s, that's the sample standard deviation, divided by the square root of n. Okay, that's the equation for the test statistic. Under the assumption, so and this is in order to use this this test statistic, the t-test, we must be making the assumption that our data follows a normal distribution. Okay, so in order or another, we could be saying that the data is following a normal distribution, or the sample size is so large that, eventually, because of the central limit theorem, x bar follows a normal distribution. So then we would be okay with this too. So either the data follows a normal distribution, or x bar follows a normal distribution, which would have to say that you have a large enough sample size in order for the central limit theorem to kick in. Okay? So this is our observed test statistic. Okay, so a p-value is the probability that the test statistic is at least as extreme as the observed test statistic. All right, so let's write this. So our observed test statistic lies somewhere on the t-distribution. Okay, so this is the test statistics distribution, right? The test statistic is random, right? It's based off of random things like the sample mean. So it's random. It has a distribution, okay? And so we observe one value of the test statistic. Say we were to, that test statistic that we observe is here, TS, okay? The p-value is the probability that the test statistic is at least as extreme as the observed test statistic under the assumption that the null hypothesis is true. So this is the t-distribution under the assumption that the null is true, under HO. Okay, and if the null is true, the null says that mu equals 0. Okay, so x bar would then be, the mean of x bar would then be 0. And so this test statistic would have mean of 0. So here is 0. Alright? Is our observed test statistic extreme? Okay? What does it mean to be extreme? That's defined by the alternative hypothesis. To not be equal to 0 is to be extreme. So to be in either of these two ends, here or here, to have been observed in either of those two ends would have been an extreme observation of the test statistic. So this is the distribution of the test statistic under the assumption that the null hypothesis is true. there's a possibility that the null hypothesis is true, and you will observe a test statistic out here on these tails, but it's very unlikely. Okay? So this probability of how unlikely it is of being way out there is what the p-value is. So if our observed test statistic was here, this TS here, and so we were at least this extreme or more extreme, okay, the p-value would be starting there, and then we also have to take into consideration the opposite, the negative TS, and then being this extreme as well. Okay, so extreme in a two-sided test is, well, you have to consider both sides. So this area that's over here, this area plus that area, that's what the p-value is. Now, if we had a one-sided test, so say we've been testing mu less than 0 and less than or equal to. Remember, null hypothesis always has that equal to sign, or mu greater than 0. Then when we're calculating our p-value, okay, if this was our observed test statistic, the definition of being extreme is now different. So here's 0. It being extreme depends on what the alternative hypothesis is. So in this case, being really greater than 0 makes you extreme. So the probability that we're in this tail over here, that's what the p-value is in that case.